Today's video is about superposition. So what is superposition? Superposition is a method which is used to solve more complex circuits. Circuits which may have multiple current or voltage sources. We do this by condensing it down to a more simple circuit which we can extract specific values of the elements from. You can think of this method as an extension of Kirchhoff's current and voltage law. It states that the value of any element across a network, like current or voltage, is equal to the algebraic sum of the currents or voltages independently produced by each source. We approach it by 1. Taking the current source and changing it to an open circuit, and 2. Taking a voltage source and changing it to a closed circuit. This is essentially you choosing which source you want to remove to simplify the circuit. Note that it's important to factor in the polarity of your current source when doing this. The next step is to determine the amount of current or voltage passing through an element, and this can be done through Ohm's law or voltage or current divider law. You can then repeat this for each source and then sum the current or voltages together. And that's essentially it. Removing the sources to simplify the circuit, then using concepts we're already familiar with like Ohm's law and current divider law, and then summing those values together. It's pretty simple, right? Now let's try an example. So here we have a circuit which has two sources. We have a 20 volt voltage source and we have a 2 amp current source. Step 1, let's eliminate a source. So I'm going to split it into two halves. So here I'm going to choose to eliminate the current source. So let's open the circuit. So now we have an open circuit with a 20 volt source, which is split between two 50 ohm resistors. Now intuitively, we know that the voltage will split evenly between these two resistors, so we can assume half the voltage value, which is 10. Now we'll set this as our V dash value. Now from here, let's remember the other way that we could split the circuit, which is closing the voltage source, so let's check that out. Now is an important time to remember our polarity. We've effectively switched the polarity by removing the voltage source, so now we can imagine -1 amp going into each of the 50 ohm resistors, thus giving us -50 volts. Now that we've simplified our circuits by removing some sources and getting a voltage value, let's sum these values together. Now this tells us that the voltage going across the first 50 ohm resistor in the original circuit is -40 volts.